My name is Steve Stover. I've worked for NASA at Kennedy Space Center for approximately 20 years. In the past few years, I've been supporting the VAB quantity distance study, where we've been looking at trying to increase the amount of solid rocket motors and hypergalls that we can process in the VAB at one time. Quantity distance, or QD, is the method that NASA uses to produce a safe siting for a hazardous facility. The large building you see behind me is the Vehicle Assembly Building, or VAB. It was built during the Apollo era to integrate the Saturn rockets as well as the Apollo spacecraft. Currently, we use the VAB to integrate the space shuttle components in 2 of the 4 high bays. In the future, we hope to be able to continue to use the VAB to integrate future launch vehicles. A few years back, preliminary analysis indicated that we may not be able to continue to use the VAB to process future launch vehicles that requires more than the solid rocket motor segments that we currently use for shuttle. The reason is that a QD arc was established for shuttle that involved 2 space shuttles in high bays 1 and 3 for a total of 16 solid rocket motor segments.
Yes, good morning. My name's Bo Brown. I'm the Explosive Safety Program Manager at Kennedy Space Center. I've also have an appointed position as the Explosive Safety Officer. At Kennedy, we work with millions of pounds of explosives and maintain a safe working environment for our personnel. We use what is called quantity distances, or QDs for short. A quantity distance is a given number of given quantity of explosives which is separated from facilities or structures where people work. Here at Kennedy Space Center, we use 3 different types of quantity distances. The first quantity distance we use at Kennedy Space Center, and it's a very important quantity distance, is inhabited building distance. An inhabited building is a facility or a structure where people normally assemble for work. And some examples of those would be administrative areas, fire stations, dining facilities, banks, and any other non-related facility to the potential explosive site. An example at Kennedy Space Center would be the distance between the Vehicle Assembly Building and the Operational Support Buildings, numbers 1 and 2. The second distance we use at Kennedy Space Center is called the interline distance. And the interline distance is a distance between 2 buildings in an operating line. These must be related to the potential explosive site and the operational flow. Example at Kennedy would be the distance between the orbiter processing facilities 1, 2, and 3 and the Vehicle Assembly Building. The final distance we use at Kennedy is called the public transportation route. Public transportation routes is a safe distance between the potential explosive site and public roads, highways, railways, and also any waterways that may be in and around Kennedy Space Center. The main thing to remember about quantity distance is that they ensure a safe location for our employees and also for our visitors when they're on Kennedy Space Center. But the main thing you need to take away from all of this with explosives is that you want to maintain the minimum amount of personnel with the minimum amount of explosives for the minimum amount of time. They can contact me through the Global. As everyone knows me as Bo Brown, I can be found in the Global as Stephen with a P-H-E-N, Douglas Brown.
Facilities were built next to the arc that was established for shuttle. If we continue to use the traditional weight-based approach to establish the QD that we use for shuttle, the arc would extend beyond the existing shuttle arc and beyond the buildings, the office-type buildings. So we would either have to relocate personnel or build a new integration facility for the launch vehicles. Either option would be costly. Our team investigated alternate methods of performing a safe sighting. One of these methods we found that DoD had been using was called a maximum credible event. And we modified that for NASA's use. What a maximum credible event allows us to do is to perform a safe sighting using engineering analysis. However, that meant we had to do a detailed analysis on each of the hazards that may be related to that particular material. The Constellation program had a requirement to be able to support up to 40 solid rocket motor segments in the VAB at one time. Following the standard weight-based approach, our arc would have extended way beyond the shuttle arc that we currently have today. In order to mitigate this, we performed a maximum credible event approach, where we looked at all the hazards, all the credible hazards, such as toxics, acoustics, thermal, propulsives, and propagation. We also performed an engineering analysis on hypergalls in order to support the Orion capsule. Although we did not produce a safe sighting for the VAB to support the Constellation program, we did advance the safe sighting process as well as created physics-based models and advanced the science. There are multiple ways where we advance the science. One way is that there was no data for large motors that were uncapped. And we were able to produce models as well as collect data on some large motors. Additionally, we didn't have data in the low flux range or thermal flux range for propellant, and we performed testing on bare propellant to see the time to ignition at low fluxes as well as time to ignition through the case testing, where we took some samples of solid rocket motors, the casing, the lining, and performed a test to collect data there. We do believe that our analysis is applicable to future work. However, since we were the first to use maximum credible event approach within NASA, there are still some details that need to be worked out in order to perform a safe sighting. For more information, there will be a narrated brief available that shows our maximum credible event approach, as well as shows some of the models that we produced along with a few of the potential arcs. As I said in my introduction, my name is Steve Stover, and my name and phone number can be found in the global. That's Stevenr Stover.